So back in 2012, there was this Brown University student, Evan Wallace,
Right?
and he built this 3D sphere, just like floating in a pool of digital water.
I remember seeing this.
Yeah, and it was rendered entirely inside a standard web browser, like no plugins or anything.
Which at the time was wild.
Totally wild. I mean, to the casual observer, it was just a neat little party trick.
Right, just a tech demo.
Exactly. But that single isolated experiment, it basically proved a concept that would ultimately, dismantle Adobe's decades-long monopoly on the design world.
It really did. It completely rewrote the architecture of how software is even built.
And that's exactly why we're doing this deep dive today. Because if you are an aspiring designer, you are stepping into an industry that has been radically transformed by the shockwaves of that exact moment.
Oh, 100%. It's a massive paradigm shift.
Right, you're looking at modern design applications, staring at these infinite canvases, and trying to orient yourself in an ecosystem that feels more like a collaborative operating system than a traditional digital sketchbook.
Wow. Yet the mental model you need now has completely inverted. For a long time, the tools we used for interface design were fundamentally solitary.
Very isolated.
Right, heavily tethered to local hardware, and frankly, completely unsuited for the medium we were actually designing for. But today, you are no longer just manipulating pixels.
What do you do then?
You are basically interacting with a live multiplayer database that just happens to have a visual interface attached to it.
That is such a crazy way to think about it, but it's so true. And to give you, the listener, the ultimate shortcut to understanding all of this, we are pulling the absolute most critical insights from the Getting Started chapters of the book, Designing in Figma, a masterclass in modern interface design.
It's such a foundational book for anyone starting out.
It really is. And our mission today is to break down those core design concepts. But, we aren't going to sit here and just read a software manual to you.
No, nobody wants that.
Right. Instead, we are going to unpack the computer science, the hidden technical traps, and the architectural philosophies that make this specific tool the undisputed industry standard.
We're going to get into why the industry shifted in the first place,
Yep.
and how to optimize your environment without, falling victim to browser limitations.
And we definitely have to talk about those very real project-destroying traps regarding color spaces.
Oh man, the color space traps. They routinely catch senior designers off guard.
Totally. But to really understand the gravity of what Figma accomplished and why this book advocates so fiercely for it, I think we have to contextualize the pain of the preceding eras, right?
We absolutely do. You have to look at the architectural limitations of the software that came before it to really appreciate where we are now.
Right, because if you were designing interfaces in the mid-2000s to early 2010s, you were overwhelmingly likely to be using Adobe Photoshop.
Yep, good old Photoshop.
Ugh, I still get phantom anxiety just thinking about managing those massive PSD files.
I mean, Photoshop is fundamentally a raster-based image editor. Its underlying architecture was engineered to manipulate static grids of pixels for print or, digital photography.
Exactly. But interface design is inherently fluid.
Right. As the web evolved to become responsive and mobile operating systems introduced countless screen resolutions, we needed scalable vector graphics.
You needed mathematical paths that could stretch and scale without just degrading into a blurry mess.
But instead, we were forcing a photo editor to do UI work. We were bloating our hard drives with multi-gigabyte files.
Wrestling with layer comps.
Yes. And just watching our machines grind to a halt because Photoshop's memory allocation simply wasn't designed to handle hundreds of vector-based interface states simultaneously.
The computational overhead was just staggering. Now, Adobe did have a tool called Fireworks, right?
Yeah, Fireworks. They originally acquired it from Macromedia.
Right, and that was actually built specifically for screen design.
It was. It utilized vectors, it understood the concept of pages and states, and it output these really lightweight files. It was a glimpse into what a purpose-built UI tool could look like.
But Adobe just let it die on the vine.
They really did.
Yeah.
They acquired Macromedia primarily to get Flash, which was completely dominating the interactive web at the time.
So Fireworks was just treated like this unwanted stepchild.
Completely starved of development resources until Adobe officially killed it in 2012.
Which perfectly coincides with the exact year the industry hit its breaking point, and a Dutch company called Bohemian Coding released Sketch.
Yes, 2012 was a massive year. Sketch won an Apple Design Award that year because it just threw out all that raster baggage entirely.
Oh, it's purely vector-based, right?
Completely vector-based, lightweight,
And-
and built from the ground up specifically for UI and UX designers.
And it was fast, like
Yeah.
incredibly fast.
Blazingly fast. It utilized macOS's native core graphics rendering engine, so it felt like a revelation because the tool was finally aligned with the medium.
It solved the rendering and the layout problems brilliantly. But, as the discipline of product design matured, a completely different, much more insidious problem emerged.
State management and collaboration.
Exactly. Sketch was a traditional, locally installed desktop application.
So if you were designing a complex onboarding flow, that file lived exclusively on your MacBook's solid-state drive.
Right. The isolation was the bottleneck. Software development is this highly collaborative process, but the design phase was totally siloed.
If a team of 5 designers needed to work on the same product, they were constantly fighting asynchronous file conflicts.
Oh man, appending like v2 final to file names.
Yes, or emailing zipped folders back and forth.
Or relying on those Dropbox shared folders where like simultaneous edits would routinely overwrite a colleague's entire day of work.
It was a nightmare. And the sheer friction of that workflow birthed this incredibly convoluted Frankenstein ecosystem of bolt-on applications.
I remember this era vividly. You had to use Sketch for the actual vector drawing. But Sketch's local architecture meant you couldn't natively prototype complex interactions or gather client feedback easily.
So what did you do? You installed a plugin called Craft.
Right, to sync your artboards to a completely separate cloud service called InVision.
And that sync was a heavy, slow process. You were literally just pushing pixels over the wire all day.
And then when the design was finally approved, you couldn't just hand the Sketch file to the engineering team.
No, because developers didn't have Macs or they didn't have Sketch licenses.
And they certainly didn't want to dig through your completely messy layer tree to find CSS values.
Exactly. So you utilized another plugin to push the designs into yet another platform called Zeppelin.
Right, which parsed the file and generated code snippets.
And then, to solve the local file versioning nightmare we just discussed, teams adopted a tool called Abstract.
Oh, Abstract, which essentially tried to force Git-style version control onto proprietary design files.
You actually had to commit your design changes and merge branches, like you were writing code.
It was a pipeline held together by digital duct tape. I mean, if one plugin updated and broke compatibility, the entire product development cycle across the whole company could just grind to a halt.
You spent almost as much mental energy managing the syncs, the uploads, and the state of your files as you did actually solving design problems.
Which brings us back to Evan Wallace and Dylan Field.
Right, the founders of Figma. After their internships at major tech companies, they experienced this fragmented, friction-heavy workflow firsthand.
And they realized the core issue wasn't the drawing tools themselves.
No, the issue was that design files were fundamentally localized in an era where software development had already entirely moved to the cloud.
So they looked at that 2012 WebGL WaterSphere demo and basically connected the dots.
They realized that if browser rendering engines had advanced to the point where they could handle 60 frames per second, hardware-accelerated 3D graphics natively.
Then the browser was no longer just a document viewer.
Exactly. It was a fully capable application platform.
They realized they could bypass the local operating system entirely, which is genius. But the engineering challenge to actually execute that is just mind-bending.
It really is. To build a cloud-native design tool that performs as smoothly as a native desktop app like Sketch, they couldn't just use standard JavaScript and HTML DOM elements.
Yes, a DOM is incredibly heavy, right?
Way too heavy. If you try to render a complex interface with thousands of layers using standard web elements, the browser will literally just choke and crash.
So what did they do?
They had to build a custom rendering engine. They wrote Figma's core in C++A, which is a highly performant, low-level language.
Okay, but browsers don't natively run C++, do they?
Right, so to get C++ to run inside a web browser, they heavily utilized WebAssembly, or WASM.
Ah, okay.
WebAssembly allows code written in languages like C++ to be compiled into a binary format that the browser can execute at near-native speeds.
Wow.
So Figma essentially downloads a tiny, incredibly fast operating system into your browser tab.
That is wild.
And then he uses WebGL to paint the vector graphics directly onto the screen, completely bypassing the browser's traditional rendering bottlenecks.
That technical architecture is the entire foundation for the why Figma paradigm shift that the book emphasizes so heavily.
Exactly. It isn't just that Figma has nice features.
Right.
It's that the underlying technology enables behaviors that are literally impossible in local applications.
So let's break down those core reasons, starting with enhanced collaboration. Because the book uses this great analogy of Google Docs versus emailing Microsoft Word files.
It's the perfect parallel.
Yeah.
But under the hood, enabling real-time multiplayer collaboration on a vector design file is exponentially more complex than syncing text.
I would imagine so. I mean, if two people are editing a Google Doc, the system is mostly just resolving the order of keystrokes.
Right. But in an interface design file, you have nested hierarchies, complex mathematical properties, constraints, relational data.
So if I am dragging the corner of a button to make it wider, and exactly 50 milliseconds later, you click on that exact same button and change its background color to red, how does the system know whose action takes priority?
It's a huge problem.
Why doesn't the whole file just corrupt?
So Figma solves this using a modified version of CRDTs, or conflict-free replicated data types.
Conflict-free replicated data types. Got it.
Unlike operational transformation, which requires a central server to dictate the absolute chronological order of every single action.
Like Google Docs does.
Exactly. CRDTs allow multiple users to make changes locally and instantly. The data structures are mathematically designed so that no matter what order the changes arrive at the server, they will always merge into the exact same final state without conflicts.
Oh, wow.
So your width adjustment and my color adjustment are treated as independent properties of the same node, merging seamlessly in real time.
The psychological impact of that engineering feat is profound. I mean, when you first experience it, seeing 5 different colored cursors flying around the screen, tweaking typography, adjusting layouts, writing copy.
It fundamentally alters how a design team operates.
It completely eliminates version control anxiety. You never have to ask who has the latest file because the file isn't a static artifact anymore.
No, it is a living, singular source of truth.
And it breaks down the walls between disciplines, you know?
Totally. You could have a copywriter actively adjusting the text inside a button while a designer is simultaneously tuning the padding of that button.
While a product manager leaves a comment right there on the frame.
It democratizes access to the work in progress.
Okay, so moving on to the actual mechanics of interface creation, the book highlights Figma's system for powerful components.
Right.
Now, anyone transitioning into this field knows the basic premise of a component, or, a symbol, as Sketch used to call them.
You create a masker element like a navigation bar,
Right.
and you reuse instances of it across your design, so you only have to update it in one place.
Exactly. But Figma's approach to memory allocation and object inheritance completely changed how we build design systems.
Yes. The architecture is based on directed acyclic graphs.
The gags.
Right. In older tools, the relationship between a master component and its instance was incredibly rigid.
Oh, I remember. If you had a master button with an icon and text, and you placed an instance of it on a screen, the software essentially wanted that instance to be a perfect locked clone.
Exactly. If you needed to hide the icon for one specific use case, or slightly alter the internal padding, the local application would literally fight you.
You would hit a wall where the software would basically say, you cannot alter the structural integrity of this instance unless you detach it from the master component.
And detaching is the cardinal sin of systems design.
The absolute worst. The moment you detach that button to make your little tweak, you sever the mathematical link.
So when the client inevitably demands a global color change 3 weeks later, your detached button ignores the update.
And your design system just fractures. It's a mess.
But Figma engineered an incredibly deep, forgiving system of instance overrides.
How does that work under the hood?
Because of how they structure the node data, Figma understands the difference between the foundational structure of a component and its superficial properties.
Okay.
So you can take an instance, deeply nest other components inside of it, radically change its scale, swap its internal elements, and manipulate its visibility.
All while maintaining the umbilical cord to the main component's core logic.
Exactly. The parent component dictates the baseline rules, but the child instance can fluidly adapt to its specific contextual environment without breaking the inheritance chain.
That is huge. And the book also details how Figma manages the sharing of these components.
Right.
Contrast it with Sketch, where teams often had to maintain these massive, monolithic, global library files.
Oh, every time you started a project, you had to load this incredibly heavy global asset library.
But Figma built a granular sharing model at the document level.
Yeah, you can turn any individual file into a published library.
So you might have a file dedicated entirely to your brand's iconography.
And another just for form fields, and another for typography styles.
And you just selectively pull in only the specific systems you need for a given project.
It is a highly modular, incredibly efficient way to manage design at scale.
And this modularity and cloud-native approach directly eliminates that Frankenstein workflow we discussed earlier, which brings us to the consolidation of developer handoff and prototyping. But I do want to heavily scrutinize this for a moment.
Sure.
Because tools like Zeppelin and Envision were deeply entrenched, purpose-built platforms. They had hundreds of millions of dollars in funding behind them.
They did.
And they specialized entirely in handoff and prototyping. Figma swooped in and attempted to bundle these entirely different disciplines into their core drawing tool. So isn't there an inherent risk of becoming a jack of all trades, master of none? Like, what if you are locking yourself into a single vendor ecosystem? And what happens when their AWS servers go down?
I mean, the vendor lock-in argument is a totally valid technical concern, and cloud outages do happen.
Right.
When Figma's servers experience downtime, you are effectively locked out of your work in a way you never were with local files.
Which is terrifying.
It is. However, the industry overwhelmingly decided that the trade-off is worth it, because the sheer friction of state management was just so debilitating.
I guess that's true.
Even if Zeppelin had superior, highly specific export features, the fact remained you had to manually trigger the sync.
Right. If you tweak a border radius in your design file and just forget to push the update to the Zeppelin server, your engineering team builds the wrong interface.
Exactly. The disconnected nature of the tools introduce an unacceptable margin for human error.
That makes sense.
Figma's built-in ecosystem eradicates the sync entirely.
Because there's nothing to upload.
Right. The handoff is no longer an action you perform. It is simply a permission state.
You just give your developers a URL with view-only access.
And when they inspect an element, Figma's engine translates the internal node data directly into CSS, iOS Swift, or Android XML right there in the browser.
Wow. So they are constantly looking at the live bleeding edge of the design.
The single source of truth is maintained effortlessly.
And I assume the same logic applies to the prototype.
Exactly. You aren't exporting flattened JPGs to Envision to string together hotspots anymore.
You are drawing interactive connection nodes directly between your native vector frames.
So if you correct a typo on a screen, the prototype is already updated. It removes all that meta work of maintaining the pipeline, allowing teams to actually focus on the product.
That's incredible. Now, the final and perhaps most globally significant pillar of the why Figma argument presented in the book is the democratization of design through price and multi-platform accessibility.
Yes, this is huge.
The source material points out this staggering statistic. Over 80% of Figma's active users are outside the United States.
That metric is a direct consequence of bypassing the local operating system.
How so?
Well, for years, professional interface design was an incredibly exclusive club. Because Sketch was built natively on macOS Core graphics, you couldn't use it unless you could afford premium Apple hardware.
Right, which is expensive.
Very. If you were a talented, aspiring designer in a developing nation or a student utilizing a school computer lab, you were completely locked out of the industry standard workflow.
So Figma essentially shattered that hardware paywall.
Completely. Because the WebAssembly and WebGL engine runs inside a standard web browser, it is entirely operating system agnostic.
You can run it on Windows, you can run it on Linux.
You can run it flawlessly on a $200 Chromebook.
The book even mentions that with recent OS updates, you can execute professional, production-ready interface design on an iPad.
It completely leveled the playing field globally.
The book uses an analogy that summarizes this entire architectural shift perfectly. It states that legacy applications trying to bolt on cloud syncing features are like manufacturers trying to infinitely tweak and optimize a combustion engine.
Right.
Whereas Figma, by starting in the browser with a custom rendering engine, essentially built an electric car from scratch.
It's the perfect analogy. You cannot achieve the fundamental performance and collaborative benefits of the electric car by simply strapping a battery to a gas engine.
The foundational architecture dictates the ceiling of what the tool can achieve.
Exactly.
Okay, so the architecture is superior. You are convinced. You are ready to adopt the tool.
Yep.
But the moment you make that decision, you run into an immediate, highly counterintuitive paradox.
Oh, the desktop app.
Yes. If the entire underlying genius of Figma, the whole electric car magic, is that it lives purely in the browser and bypasses the operating system, Why does the book dedicate an entire section to aggressively advising you to download and install a local desktop app?
I know, it feels like an immediate contradiction.
It really does. Why on earth would I download a desktop app?
It does seem paradoxical at first glance, but it comes down to the friction between the sandbox security models of modern web browsers and the deep system-level access required by power users.
Okay, unpack that for me.
Well, yes, anyone can view or lightly edit a file in Chrome or Safari. But if you are spending 40 to 50 hours a week executing complex interface designs, the browser environment introduces several highly specific bottlenecks.
And the absolute biggest bottleneck for me and for any serious designer is typography.
Exactly. Web browsers are designed with strict security sandboxes. They physically cannot natively read the internal file directories of your local hard drive.
Which is a crucial security feature, right? To stop malicious websites from scanning your computer.
Right. However, this means that if you open Figma in Google Chrome, it only has access to a standardized library of web fonts, like the Google Fonts directory.
So if you work for a major corporation that utilizes a proprietary custom licensed OTF or TTF font file that you have manually installed in your Max Font book,
the browser version of Figma is completely blind to it. It cannot render your brand's typography.
But wait, doesn't Figma have a workaround for that?
They do. They engineered a workaround for the browser called the font installer.
Right.
It's a localized system daemon that runs in the background of your OS, acting as a bridge to feed your local font securely into the browser tab.
That sounds clunky.
It is inherently clunky. It relies on background services staying active, and it can crash.
And the desktop app completely bypasses that friction.
Completely. Now let's be technically clear about what the desktop app actually is.
Okay.
It is not a native Mac or Windows application in the traditional sense. It is an Electron app.
Right, Electron.
Precisely. Electron is a framework that essentially wraps a Chromium browser engine inside a native application shell.
So you are still technically running a browser?
Yes, but it is a highly customized, dedicated instance of Chromium that possesses elevated system-level permissions that a standard web browser lacks.
And because it has those elevated permissions, the desktop app has instantaneous native access to every single font installed on your machine.
Exactly. No background bridges required.
That alone is worth it.
Yeah.
But beyond typography, the performance stability has to be a massive factor, right?
Absolutely. If I'm using Firefox or Safari as my primary daily browser for research and communication, I don't want to be forced to keep a separate Chrome window open just to ensure optimal WebGL performance for Figma.
Right. The desktop app provides a perfectly stable, highly optimized environment that isolates your heavy design work from the memory leaks of your other 50 open browser tabs.
Plus, the desktop app also utilizes those elevated permissions to vastly improve your export workflow.
How so?
Well, think about when you need to export 50 individual iconography assets to hand off to engineering.
Okay.
A standard web browser's security protocols will not allow a website to suddenly dump 50 individual files into your downloads folder.
Right, it restricts bulk downloads by forcing the application to compress everything into a single zip archive.
Which is incredibly tedious. You have to locate the zip, expand it, delete the archive, and then organize the contents.
Oh, I hate doing that.
But because the Electron desktop wrapper has direct write access to your file system, when you hit export, those 50 PNGs or SVGs are instantly populated exactly where you want them.
It removes tiny layers of friction that just compound into massive time savings over a career.
And we cannot overlook the optimization of screen real estate.
Oh, true. A standard browser interface, the URL bar, the bookmark ribbons, the navigation buttons, it all consumes critical vertical pixels.
And in complex UI design, maximizing your viewable canvas is essential. The desktop wrapper strips away all the browser Chrome, dedicating the entire window strictly to the application interface.
The book also details some massive workflow upgrades specific to the desktop app's window management, and honestly, I utilize this constantly. Shift-Command-N on a Mac or Shift-Control-N on Windows.
It's a game changer. That command opens a completely new application window, separate from your main tabbed interface.
So if you are operating a multi-monitor setup, this is a profound advantage.
Oh yeah, you can tear off a window containing your master design system library and park it on your left monitor, while your active product design file remains on your primary display.
But you know, the most powerful application of this, though, is opening the exact same file in two separate windows.
Yes.
You can have one window on your main monitor zoomed in 800% on a complex vector Bezier curve, you are fine-tuning.
While you're doing that, the second window on your other monitor is locked at 100% zoom, showing the entire mobile application screen.
Right. So as you adjust the micro details of the curve, you can monitor the macro impact on the overall composition in real time without constantly panning and zooming back and forth.
It's brilliant. So the tactical verdict is absolute.
Yeah.
Use the desktop app.
Period.
The book recommends diving into your account preferences immediately and toggling the open links in desktop app setting.
Yes, do that immediately. By doing this, whenever a product manager or developer sends you a Figma URL in Slack or email, clicking it bypasses your default web browser and securely routes the command directly into your active desktop workspace.
It just maintains a seamless flow.
Okay, so once you are properly situated in the desktop app, you are finally faced with the actual workspace.
The interface.
Right. And if Photoshop was historically organized like a photographer's darkroom, Figma requires a completely different spatial metaphor. We really need to construct a robust mental map of the interface.
And we aren't going to list what every single button does. That's just tedious.
Right, but we need to understand how data flows through the application and how you manage the infinite canvas.
So the mental map is best understood by recognizing how Figma segregates context. The interface is highly reactive. Let's start with the top layer.
Okay.
In the desktop wrapper, the absolute top boundary houses your document tabs, functioning exactly like a browser.
Right.
But the critical element here is the home icon on the far left, which drops you into the file browser.
And the file browser is effectively your cloud file system. It's where projects are segmented into teams, projects, and drafts.
Exactly. And the book highlights a critical bridge feature here for teams migrating from legacy tools. The native sketch importer.
Oh, that was so important when Figma first launched.
Because Figma understood they needed to reduce the switching cost, so they built an incredibly robust parser.
You can just drag a heavy proprietary .sketch file directly into this browser, and Figma servers will mathematically translate the core graphics data into their native WebGL structure with remarkable fidelity.
You don't lose your historical work. It's amazing.
Now, moving into an actual active file, the perimeter of your screen handles distinct functional categories.
Right. The top toolbar is your primary point of creation, but its true power lies in its reactivity.
What do you mean by that?
Well, if your canvas is empty, it displays foundational tools, frames, shapes, the pen tool. But the moment you select multiple elements, the toolbar instantly reconfigures to display Boolean operations, allowing you to mathematically add, subtract, or intersect vector paths and alignment controls.
Ah, I see. It adapts to what you're doing. And, if you are ever lost trying to find a specific function buried in a drop-down menu, you should immediately train your muscle memory to hit Command on Mac or Cruise on Windows.
Yes, the global search bar.
It invokes a highly optimized global search right in the center of your screen. You bypass the UI entirely.
You just type blur or flatten or outline stroke, hit enter, and the command executes.
It is the fastest way to navigate the application.
Now, the structural backbone of your file lives on the left side of the screen, the Layers panel.
Right.
This is essentially a visual representation of the Document Object Model, or DOM. Every single frame, group, text node, and vector path is represented here in a strict hierarchical tree.
And if you are building anything remotely complex, like a dense enterprise software dashboard, this DOM tree becomes an absolute nightmare.
It really does.
You end up with frames nested inside auto layout groups nested inside main components. Trying to parse that structure visually is exhausting.
So what's the trick?
I rely heavily on the shortcut Option-L or Alt-L on Windows. It functions as an instant global reset.
Oh, I love that one.
If your layer tree is massively expanded and chaotic, hitting Option-L instantly forces every single group and frame to collapse back into their highest level parent folder. It cleans up your mental workspace instantly.
It's a lifesaver. Conversely, the right side of the screen is the Properties panel.
Right, so if the left side manages the structure of your data.
The right side manipulates the styling and behavior of the data. And just like the toolbar, it is aggressively contextual.
Right. Select a text node, and the engine populates the panel with typography variables.
Select a vector path, and it exposes stroke widths, fill properties, and coordinate data.
And this right panel is where the workflow consolidation we talked about earlier physically manifests. It contains 3 distinct tabs: Design, Prototype, and Inspect.
You spend the vast majority of your time in the Design tab, obviously, manipulating aesthetics.
Right.
But when you need to define logic, you click the Prototype tab. The canvas immediately changes state, exposing interaction nodes on your elements.
Allowing you to define transition animations and scrolling behaviors without ever leaving the file.
Exactly. And the Inspect tab is that real-time CSS and code translation engine we discussed for developer handoff.
It exposes the raw mathematical values of whatever element is selected.
Now, managing all these panels on a smaller display, like a 13-inch laptop, can induce severe claustrophobia.
Oh, definitely. The interface starts aggressively encroaching on your canvas.
The essential command here is Command. Executing this instantly hides the entire graphical user interface.
Yeah.
The toolbar, the layers, the properties all vanish.
You are left with nothing but your pure design rendered against the canvas.
It is vital for maintaining focus or doing quick, unencumbered presentations.
Which brings us to the canvas itself. This is where the true power of the WebGL engine is evident.
It really is. It is an infinite coordinate-based void.
Unlike legacy tools where you had to define a strict document boundary before you began, Figma allows you to continuously expand outward.
You just place designated frames onto this void, which act as specific device boundaries, like an iPhone screen or a desktop browser window.
But navigating a boundless void requires a completely different physical interaction model.
Yeah, if you just wildly scroll, you will literally lose your design in the gray expanse.
You have to master the zooming matrix.
The engine binds zoom states to fundamental numeric keys. Pressing 0 forces the camera to exactly 100% pixel accurate scale.
Okay.
Pressing 1 mathematically calculates the bounding box of every single element you have ever placed on the canvas and adjusts the camera zoom so that your entire project is visible within your monitor's frame.
But the most powerful navigation sequence and a concept that completely changed how fast I could maneuver is relying on the specific object zoom.
Right, pressing 2.
Yes. If I am lost, or if I need to instantly jump across the canvas to a specific nested icon, I locate it in the left-hand layer tree, I click its name, and I immediately press 2.
And the camera instantly teleports and zooms tightly onto the exact coordinates of that specific element.
It's basically magic, but because pressing 2 often zooms you in far too aggressively, you immediately follow it with 0.
Ah, yes. The sequence 2, then 0.
It instantly teleports you to an object and frames it perfectly at 100% scale in the dead center of your monitor. It becomes an automatic reflex.
To master the rest of these mechanics, the book points out an incredibly clever psychological trick built into the software.
What's that?
If you press Ctrl-Shift, Figma summons an overlay containing every single keyboard shortcut mapped within the system.
Okay.
But it acts as a gamified mastery tracker. Every shortcut command you have successfully executed in the past is permanently highlighted in bright blue.
Wait, really? I actually didn't realize it tracked what you've used.
Yeah. The commands you haven't discovered remain gray. It physically and visually nudges you to adopt more efficient workflows by showing you exactly what you haven't learned yet.
That is such an elegant onboarding mechanism. So at this stage, you understand the architecture, you have bypassed the browser bottlenecks, and you have internalized the spatial navigation of the canvas.
You are technically ready to begin pushing pixels and defining the visual language of your product.
But right at this exact moment, at the peak of your confidence, there is a massive, highly technical trap waiting to destroy the integrity of your entire project.
Yes.
It is an invisible landmine that causes endless, bitter friction between design and engineering teams. We must address the complexities of color spaces, specifically the dangerous allure of the unmanaged setting versus the sRGB standard.
This is so critical. To avoid this trap, we have to drop into the underlying mathematics of how screens render color and how data is transferred from a design file to a live web browser. We have to define what a color space actually is.
Let's do it. At a hardware level, a color space is a mathematical boundary, right?
Exactly. It defines the maximum spectrum of colors a physical display panel is capable of emitting.
So a cheap, heavily compressed LCD panel cannot produce the same blindingly vibrant reds or deep pitch black shadows as an expensive high-end OLED display.
Right. They physically possess different color volumes.
Because of this hardware discrepancy, the tech industry required a universal baseline.
And in 1996, HP and Microsoft collaborated to create the sRGB color space.
Now you have to remember the hardware constraints of 1996 heavy, dim CRT monitors.
Right. sRGB was engineered as the ultimate least common denominator. It is a relatively small, constrained color volume.
But the agreement was absolute. Virtually every single digital screen manufactured, no matter how cheap or low quality, can accurately reproduce the specific colors within the sRGB boundary.
And because it guaranteed uniformity, sRGB became the undisputed hard-coded default standard for the entire World Wide Web.
Browsers render CSS colors based on the mathematical assumptions of sRGB.
But monitor technology obviously didn't freeze in 1996. Display hardware improved exponentially.
Exactly. Fast forward to 2015, and Apple introduced iMacs and MacBooks utilizing a new hardware standard called Display P3.
Right. Display P3 is a wide gamut color space.
I don't know, in mathematical terms, the physical volume of colors a P3 display can project is roughly 25% larger than sRGB.
It's a huge difference. The extremes of the spectrum, the neon greens, the piercing cyans, the intensely deep reds, are pushed significantly further out.
And here is where the trap perfectly baits the designer.
Oh, yeah.
Because I am sitting at my desk utilizing the optimized Figma desktop app on my state-of-the-art wide gamut MacBook Pro display. I open my Figma preferences, and under the color space settings, I see two options, sRGB and unmanaged.
Right. And the unmanaged setting is a directive to the Figma rendering engine. It essentially says, do not constrain my visual output to the old 1996 sRGB mathematics. Let the WebGL engine directly access the maximum color volume my specific physical monitor is capable of.
As a designer, the temptation is just overwhelming. Why wouldn't I select unmanaged? I want my interface to be stunning.
Of course.
I want my primary call to action buttons to utilize the most vibrant, intense colors my machine can produce. So I select unmanaged, I pick a piercing neon gradient, and the design looks absolutely incredible on my canvas.
But you are designing an interface for a collaborative team, ultimately destined for the web, not a static piece of concept art meant only for your specific screen.
Right.
If you design it unmanaged, you immediately fracture the single source of truth.
Let's track the cascade of failures here. First, collaboration breaks down.
Yep.
If my lead developer is reviewing my Figma file on a standard external DAL monitor that only possesses an sRGB hardware gamut, they physically cannot see the intense P3 colors I defined.
The WebGL engine on their machine will silently clamp those extreme values down to the nearest dull equivalent.
So we are looking at the exact same file, but perceiving two entirely different visual realities.
The collaboration breakdown is bad, but the engineering handoff is where the trap fully detonates. This is the absolute deal breaker.
Why? What happens?
Well, the Figma architecture currently possesses a massive bottleneck regarding export pipelines. Regardless of what color profile you're visualizing locally in the desktop app, Figma's cloud servers mathematically crush every single exported asset, every PNG, every JPG, back down into the sRGB color space.
Wait. I really want to emphasize this. Even if I purposefully define an intense wide gamut color in unmanaged mode, the moment I ask Figma to generate an image file or code snippet, the server overrides my intent and squashes the color data into the smaller 1996 boundary.
Yes, the server forces the conversion to maintain web compatibility.
That is devastating.
And it is even more destructive when we look at the CSS code generation in the Inspect tab. When the developer clicks your button to copy the color values, Figma generates a standard HEX code, or an RGB string.
And as we established, the rendering engines of web browsers like Chrome, Safari, and Firefox interpret standard HEX codes and RGB strings as sRGB data by default.
Precisely. So you spend hours meticulously fine-tuning a breathtaking wide gamut P3 interface in unmanaged mode. The client approves it on your laptop.
Right.
You hand off the exact mathematical HEX codes to the engineering team. The developer writes the code flawlessly. The product launches.
And the client opens the live website on their browser, and every single color looks completely washed out, muted, and dead.
Exactly. All the neon vibrancy is gone because the browser interpreted the code through the restricted sRGB lens.
It leads to catastrophic friction. I mean, the designer accuses the developer of ignoring the specs, and the developer defensively and correctly proves they utilize the exact HEX codes provided by the design tool.
The failure wasn't human error. It was a fundamental misunderstanding of color volume mathematics and web rendering pipelines.
And the book states definitively that while it is intellectually exciting to design with the full spectrum of modern hardware, there is zero practical justification for doing so until wide gamut CSS standards like Color Display P3 achieve ubiquitous cross-browser global support.
Right, and until design tools natively support end-to-end P3 export pipelines.
So the absolute golden rule for any designer, junior or senior, is to immediately open your Figma preferences and permanently force the application into the sRGB color space.
Yes, you are intentionally restricting the capabilities of your expensive monitor, but you are guaranteeing absolute mathematical parity.
A slightly less vibrant color that looks 100% identical on your screen, your developer's screen, and the final production website is infinitely more valuable than a beautiful illusion that shatters the moment it hits the internet.
designing for software requires extreme pragmatism. You are managing constraints.
Absolutely. Well, we have dissected a massive amount of dense architectural and technical theory today.
We really have.
To synthesize everything for you, the designer stepping into this ecosystem, you are not just learning how to draw vector shapes, you are adopting a cloud-native operating system.
Right. Figma's reliance on WebGL, WebAssembly, and CRDTs completely dismantled the isolated, friction-heavy, multi-app workflows of the past.
It consolidated the entire product development lifecycle design, prototyping, and engineering handoff into a singular, globally accessible, real-time environment.
You are stepping into the electric car.
Exactly. We have mapped out the interface for you. We have justified why bypassing the browser sandbox with the desktop app is critical for professional performance.
And we have armed you with the technical knowledge to avoid the devastating color space trap that ruins production launches.
You have the foundational context, which means the only thing left to do is to actually open the canvas and start building.
Time to put it into practice.
But before we leave you, I have a specific request. Navigating the technical complexities of a design career is an ongoing process. If this deep dive provided you with clarity, and if you want to continue mastering the mechanics of this industry, please follow us for more technical design breakdowns and career-building content.
We will continually deconstruct the tools and systems that define modern product creation.
Because the landscape is always shifting, and maintaining a deep understanding of the underlying technology is what separates a technician from a true product architect.
Exactly.
And to wrap us up, we want to leave you with a final provocative thought. Think deeply about the origin of this entire paradigm shift.
Right. Evan Wallace's WebGL water sphere in 2012.
That wasn't built to revolutionize design tools. It was an exploratory experiment on the fringes of browser capabilities. Most people just dismissed it as a novelty.
And a few perceptive people looked at that mathematical rendering and realized it possessed the specific underlying architecture required to completely annihilate the legacy desktop app monopoly.
So the question you should be asking yourself as you look at the industry today is, what is our current equivalent of the water sphere?
It's a great question. What highly experimental, rough around the edges technology are you seeing right now that everyone is dismissing as a toy?
Is it the raw, unrefined outputs of generative AI layout models?
Or is it the spatial computing paradigms of mixed reality headsets, fundamentally altering the coordinate systems of interfaces?
Whatever it is, the architecture that will render our current workflows obsolete in 10 years is already being compiled somewhere right now. It's something to think about the next time you hit Command-N and stare at that infinite gray canvas.
Until next time.